We're going to go into section 6.5, and what we do in this section is look at a special rule for factoring, where we have a binomial x squared minus 9, which we call a difference of squares. And we would say a difference of squares. So what this means is that we have this binomial here that has x to the power of 2, and we're going to subtract a perfect square like 9. And remember that perfect squares we have are 1, 4, 9, 16, 25, 36, and so on, right? Because if we take the square root of these, we would end up with a perfect number, such as 6, 5, 4, 3, 2, and 1. So let's look at our first example. And basically, before that, we can see that a squared minus b squared. What this means is that we are going to be able to rewrite this as a minus b times a plus b. And so what exactly does this mean? Let's look at x squared minus 81. That's our first problem there. If you notice right in front, we can always assume that there is a 1 in the front of x squared. We can always assume that there is a 1 there. So we have a perfect square where 1 is, which is our 1, and a perfect square which is 81. We take the square roots of those. This is 1 and 9. So we can actually rewrite this as 1x squared minus 9 squared. So being that we can do this right here represents our a. And this right here represents our b in this equation. So a is equal to 1x and b is equal to 9. So what we're going to do is we're going to write this as a minus b and a plus b. So we would say x minus 9, x plus 9. And we could check this answer by multiplying back. So if we were to multiply the answer, which was x plus 9, x minus 9, and x plus 9, x times x gives us x squared. 9 times x gives us 9x, and negative 9 times x is negative 9x, and then 9 times negative 9 gives us negative 81. Now what's interesting here is that we have our x squared, but 9x minus 9x cancel out. We have 0. So we are only left with x squared minus 81.